Hi, everybody. Welcome to the NVIDIA Omniverse OpenUSD Insiders live stream. We're so honored to have you join us today. I'm also honored to have my coworker here, Katie. Hey, Katie.
Hey, Edmar. Thanks for having me.
Thanks for you coming. I mean, now you're officially a veteran. This is your at least second appearance on a live stream. So I got to get you a live stream jacket. I'll get that
Yeah.
out to you because now you're in the club.
Yeah. I'll take any swag.
Katie's here because we have a very special live stream. Also, another one of our colleagues, Gotham, will be joining us in a few minutes. And we have a super, super special guest from Voxel 51. We're going to bring him up in a second. We're going to go through some quick announcements. But just so you know what you're in tune for in the next hour, we're going to be taking a look at the future of AV simulation with NVIDIA Omniverse and Cosmos. We're going to show you how tools like CARLA and Cosmos and NuRec help generate diverse, high-fidelity data to power some next-generation autonomous vehicles. So from real-world drive reconstruction to edge case simulation, this is going to be a great hour. We welcome you to put in your questions, your comments. If you want to share your projects, tell us what companies you're from, where you're watching from. Absolutely engage in the chat. We actually have a bunch of people from NVIDIA who are hanging out in the chat as well. So I think some people from the Cosmos team are watching. So if you have any questions on Cosmos along the way, even if it's not directly related to what we're talking about specifically today, feel free to ask in the chat, and I'm sure we'll be able to help you. Before we get the party started and bring Dan and Gotham up, we're going to go over some quick announcements. Katie's going to jump in on a couple of these things, I think. We're going to go through these relatively quick because we have a lot to cover today, but I definitely want to make sure we highlight some of these on the screen with the QR code so you can bring up the link easily and look at any interesting things that affect you. We're also going to post a link to these all in the description of the video as soon as we're done wrapping up the live stream today. Again, if you're watching this live, you can always watch this again on our YouTube channel afterwards, anytime. All right, so we're going to get started. The reason why we have a bunch of announcements is we just had a couple of really great events like Computex and GTC Paris, which was a lot of fun from our ambassadors to community members who are attending. Got a lot of great feedback. So some of these announcements come straight from there, including this one. NVIDIA builds world's first industrial AI cloud for European manufacturers. So that QR code will bring you right to that blog. And I highly recommend you check this out. Siemens and NVIDIA are expanding the partnership to accelerate AI capabilities in manufacturing. Obviously, Siemens is no stranger to viewers of the live stream. This blog is also going to really help you get up to speed on that. NVIDIA releases new AI models and developer tools to advance autonomous vehicle ecosystems. So Katie, what is this one about?
Yeah, so we have actually a decent amount of newly available open source models and tools, in addition to data to help you kickstart your data generation pipelines for AV development. So we have some new Cosmos models. We have Predict 2, which can be post-trained for data generation. We have our Carla integration, which we'll be talking about in just a few moments, in addition to new autonomous vehicle data available on our physical AI data set on Hugging Face. So definitely go check that out. We have some Cosmos generated data, as well as a few reconstructed scenes to help you kick off the NuRec pipeline, which again, we will go into more detail in just a few moments.
Amazing. Okay, so there's that QR code. NVIDIA brings physical AI to European cities with a new blueprint for smart city AI. Regular viewers will probably know that blueprints make things really easy for you to get started. It's kind of like a template, so you're not just start from scratch. So I highly recommend you check this out as well if you're involved with any kind of digital twinning for smart cities. NVIDIA Drive full stack autonomous vehicle software rolls out GTC Paris. Is this one you want to touch on, Katie?
Sure. Yeah, this is really exciting. This is something that has been in the works since I've been at NVIDIA, but our end-to-end autonomous vehicle software is now in production. So it's a big step towards wide-scale autonomy, and we are very excited.
Awesome. So check out that QR code to get the full scoop. Again, we'll post these links in the chat and in the description. Germany builds its AI Autobahn with NVIDIA. I haven't seen the story yet, so I'm gonna check this blog out after the live stream. But I imagine this is also going to be very helpful for anyone involved with autonomous vehicles. The QR code will bring you to that blog as well. Scale realistic robot simulation using the NVIDIA Nemo agent toolkit for physical AI. Again, an announcement straight from GTC Paris. That QR code will bring you right there. Develop custom physical AI foundation models with NVIDIA Cosmos Predict 2, which Katie just touched on a second ago.
Yeah, so to go into slightly more detail, Predict 2 can generate future video states from images, video, text prompts. So you can you can extend your data, whether you're using it to train autonomous vehicles, robots, any sort of physical AI, and really improve the value and take your data farther.
Amazing. Definitely check out that blog. Building photorealistic digital twins with Siemens Team Center, digital reality viewer. So we showed this GTC Paris. We also showed an early version of this at the last GTC as well. Really powerful demonstration. Check out this blog. We always had amazing turnout whenever we do this booth at GTC because people are just totally blown away by what's shown on the screen and the amount of resolution there. Super high quality simulation. NVIDIA Research casts new light on scenes with AI-powered rendering for physical AI development. Definitely check that out there at the QR code. NVIDIA scores consecutive win for end-to-end autonomous driving grand challenge at CVPR. Katie, this looks like something you might know about.
Yes, so it is related to the announcement a few slides ago that our AV software is now in production. This is the research side of things. We have developed an end-to-end autonomous driving model that we entered into the CVPR competition for the second year in a row. It performed the best given a set of safety challenges. So yeah, we're continuing to kind of. Sorry if you can hear my dog.
No, it's okay. Listen, it's a pet-friendly live stream.
But yeah, so we're continuing to kind of keep the foot on the gas in development.
I love that. That's awesome. Okay, accelerating AV simulation with neural reconstruction world foundation models. This is also
yes. So again, this is what we're going to really dive into in the next few moments. We are kind of really building out these pipelines for data reconstruction and generation to really bolster your development pipelines, because these end-to-end models that we keep bringing up really data hungry, really require physically based high fidelity data, and we are developing these tools with our partners to help developers achieve that.
So this is a great complimentary blog specific to this live stream, right? This is the one that we're going to be really diving into. So absolutely check out this. We're going to post this link probably a couple of times throughout the live stream, but this is a great blog to check out following the live stream today. And then we have simplify end-to-end autonomous vehicle development with new NVIDIA Cosmos World Foundation models. We've covered what Cosmos is and World Foundation model, but Katie, do you want to touch on this one a little bit more?
Yeah, so this really dives into what you can do when you post-train the various Cosmos models for AV development. So as I mentioned, we have Predict, we have Cosmos Transfer, which we will also get into in this live stream. Really powerful tool for scaling your data variation. And then we also have Cosmos Reason. So this blog is a nice kind of deep dive into the different ways you can post-train Cosmos for your various development needs.
Amazing. Katie, I'm so glad you're here. That was super helpful. I wouldn't have been able to do this without you. So thank you, Katie, and your dog. It's great. And then for people who want to check out resources just across the board, these are the QR codes for our ad event calendar, which makes it really easy to see the upcoming office hours, the live streams, any kind of special keynotes or events. You can add those easily to your calendar and see what's coming up from the ad event link there. Our official forums, that's where you get official support for most of our technology, not all. Some of the official support is handled on GitHub, but always a good place to start with the official forums, especially for tech like Isaac Sim. That's our Omniverse Discord server there. Welcome you to join the community. We have so many great developers there helping each other every single day. It's just a fantastic place to not only talk about projects, but also share your work. We have a great job board channel, lots of great channels per topic. Highly recommend. And then if you want to go to our community page, we have a great overview of all of our Omniverse ambassadors, one of which I'll talk about a little bit later in the stream, Michael Wagner, who's been doing some really cool work and sharing his work on LinkedIn that he's just open sourced a really nice extension. So we'll touch on that a little bit later, but that's our community page. And really happy to actually kick things off now with our official stream. I'm going to bring in first Gotham. Gotham, how you doing?
Hello, I'm doing well. How are you, Edmar?
I'm great, man. I'm so glad you're here to join us. Really happy. I really had an enjoyable time during the tech rehearsal. Why don't we do this? Because I actually should have introduced Katie properly. So why don't you each give your kind of your role in video, what your specialty is, and what you'll be covering today, and then we'll bring in our very special guest.
Okay, should I start? Okay.
Yeah, go ahead, Katie.
So as mentioned earlier, I'm Katie Washabah. I'm the product marketing manager for autonomous vehicle simulation at NVIDIA. And I'm here to kind of help set the stage for, again, sorry, my dog also would like to be in the live stream.
No, it's okay.
But yeah,
What's the dog's name?
His name is Tully, after House Tully in Game of Thrones.
I love it.
for all the nerds out there.
Love it.
But yeah, so I'm here to set the stage for what we recently announced at CBPR and kind of why we're doing what we're doing at this time.
Amazing. Okay, cool. And Gotham, tell us a little about your role here.
Sounds good. Nice to meet everybody on the live stream. I'm Gautam Schollinger. I'm a product manager focused on autonomous vehicle simulation here at NVIDIA. So we're focused on all things developer. So how do we help developers reconstruct data sets, generate new synthetic data sets, and curate and search through them? So we have cloud APIs for all of them. I'm excited to share all of that with you, and you'll hear more. So
awesome. Okay, I'm going to stop showing my screen so we can make everybody's camera a little bigger, especially for our next special guest from Voxel 51. Let me press the magic button here. Dan, you've been teleported to the live stream. Thank you for joining us.
Hey, everyone. How's it going? Excited to be here today.
We're very excited to have you. I can't thank you enough for joining. Again, I had a great time yesterday doing the little warm-up. Why don't you tell us a little about yourself, your background, and, of course, Voxel, and then what you're going to be covering today. And then I think we're going to hand it over to Katie to kind of set the stage for what kind of problems we're seeking to tackle.
Absolutely. My name's Dan Grau. I'm a machine learning and developer relations at Voxel 51. I've been working with our great friends here over the last probably year plus at this point on the Omniverse product, building out new ways to work with autonomous vehicle data sets. And coming from Voxel 51, we're all about computer vision data sets, right? We believe here, if you can't see from my shirt here, that data eats models for lunch. All good models start with a good data set, and 51 is a open source tool, completely free to use, that help build the best computer vision data sets out there. So really excited to show you what we've been building together with Omniverse.
That's amazing. So we're going to put the link to Voxel 51 in the chat. We'll probably put it a few times during the live stream. Feel free. This is your opportunity, anyone watching, to ask your questions and comments to any one of our guests here. And even if it's something we can't cover, we'll try to help you in the chat as well. Amelia, our producer, is helping there right now. We're going to go through. Let's start. For anyone who's just joined us today, we're going to cover autonomous vehicle simulation with NVIDIA Omniverse and Cosmos. And we're joined by Dan from Voxel and my colleagues from NVIDIA, Katie and Gotham. So Katie, why don't we set the stage here for what we're going to be talking? We talked about a few minutes ago on the news slide that we have this great blog, which Amelia will post again, that kind of goes things into perspective in writing. But why don't you tell us what kind of challenge are we trying to fix here?
For sure. And I think in the slides that we have prepared.
Do you want me to show Gotham screen?
yeah,
Yes,
go for it.
Okay, here we go.
Okay, perfect. Yes, so in our lightning round of headlines, we mentioned end-to-end models, we mentioned data generation, data reconstruction, to kind of put this all together as to what exactly is happening here. Wanted to kind of take a few steps back and explain kind of where we're at in the development of physical AI. So physical AI refers to robotics, autonomous vehicles, kind of any kind of physical embodiment of AI in the world. And it's been under development for the past couple of decades. But as you may have noticed, it's really taken off in the past couple of years. And that's really due to a fundamental shift in the way these autonomous machines are being developed. And it's a transition from a modular architecture where you have dedicated models for different perception and planning tasks, to now these unified end-to-end models, end-to-end foundation models that map sensor data directly to action. So in order to train these models to be able to kind of handle the complicated diversity of the world, we need a lot of data. And as Dan mentioned, we need good data and different tools to really curate, generate, and process it. So in terms of autonomous vehicles, we kind of have three different data sources. We have real world data collected by cars driving on the road. This data is high quality, so the sensor data we need for these end-to-end models. However, it's limited in diversity. I mean, as you're probably aware, when you drive around, you don't really experience that many edge cases or near miss scenarios that you would want the vehicle to be able to experience. But again, probably wouldn't want to go out and collect them yourself. So we can supplement this with simulation. However, with simulation, we're traditionally limited in kind of the scalability of scenarios. So now with recent developments in generative AI, we can take the quality of real world data, that physically based high fidelity data, and now add that diversity of the real world and really scale it out. So in terms of quantity of what we're aiming for, internally, our end-to-end AV model just to pre-train is 20,000 hours of driving data. We then need tens of thousands of hours for post-training for that model to be able to generalize to new scenarios, new geographic locations. And with these tools that we're about to walk through with NuRec for reconstruction, Cosmos for data generation, we can amplify that data and achieve those tens of thousands of hours with the quality to make sure that this model can really map that sensor data to the correct action in the real world. So with that kind of in mind, I will pass it over to Gotham to really dive deep into what we've announced.
Sounds good. Thank you, Katie. So even before moving on from this topic, I just want to kind of set the stage and say, as Katie mentioned, these APIs are kind of fundamental to how we want to enable developers. So the way we package things historically is in this concept called blueprints, and you're going to hear this word from Omniverse and NVIDIA a lot, which is a blueprint is a reference workflow which shows you how to use our services and our capabilities to help you generate for example, realistic sensor data. So in this case, I'm showing you the sensor simulation blueprint specifically for autonomous vehicles, where you're able to take real world sensor data, which can come into, you can either model 3D content with procedural tools, or you can use neural reconstruction and reconstruct from real world drives. You're able to create 3D worlds out of these real world drives, and then enhance those 3D worlds with physics-based actors, animated vehicles, and then render sensor data. Right? I'm not going to walk through the individual pieces. I'm happy to cover that if people are interested. The main service we're talking about here is Sensor RTX. The Sensor RTX service allows you to take that 3D content and render sensor data. This content could be physics-based content, could be Gaussians floating in space, basically a point cloud, and we're able to take those different sources of inputs and render sensor data with, for example, lens distortions and realism, the things you care about. And then we're able to take that sensor data, and as Katie said, we're able to amplify the realism, the diversity. For example, in this case, we took a simple highway scene where there's one parked car on the shoulder, and then we're able to convert that into a snowy landscape with mountains in the back and show you that diversity which you're able to get. All of this can be done for open or closed loop simulation. The way we enable developers and partners is we work with them to figure out what pieces are most valuable to them. Some partners want Reconstruction, some want Cosmos, and we enable them with those APIs. And it's almost like a pick and choose model, and it's a menu of all the things you could do. So this is kind of the way we engage. I want to show you some examples of how we've done this. So one specific set of APIs that we care about is for neural reconstruction. So we have APIs that allow you to take a real world drive and reconstruct a Gaussian representation out of that. So in this case, you're actually watching a playback replay of a real world drive in the form of Gaussian. So none of these actors exist, and it's not an image that you're seeing. What you're seeing is a picture taken as you fly through the Gaussian representation of the scene. And that's kind of the representation we're able to get. We're also able to insert physically based actors and objects into a Gaussian representation, composite it, add shadows, model with ray tracing. We're able to get realistic insertion of actors in the scenes. And we also have generative enhancement APIs, right? So let's say you want to shift the trajectory of the vehicle by a few meters, and or look in a new direction which you did not reconstruct, we're able to use generative enhancement APIs to in-paint those gaps and give you that realistic sensor data at high fidelity. So these are some of the APIs which we're working on. I actually want to give the stage to Dan to kind of talk about how we're connecting our reconstruction APIs with Voxel 51. So Dan, come on board.
Thank you, Gotham. And let me pull up my screen. I can pull up some live demos here. Everyone loves a good live demo.
Go for it. Yeah.
All right. Just give me the switch flip here, and we should be ready to roll. Thank you, Edmar. So what we're looking at here is actually the Voxel 51 app. We built this open source tool called 51, which allows you to load any of your computer vision data set across any domain, this case, of course, obviously AV, and begin visualizing and working with them in a AV context. So what we're looking at here, we're actually looking at the new scenes data set here. And just to give you guys an intro of what kind of capabilities we're capable of here, you're putting yourself no longer diving through folders. We're not looking at this through matplotlib projected images. We're doing this in a context just how the car would be, right? So when you have these drives that you're pulling off the car, you can begin to pull them off. I can see all the different labels on top of them, as well as all the different 3D points. And this is all configurable. Everything you see here can be changed. It's all flexible. You can go into this, make your points a little bit bigger if you want to make them brighter. We can even add things like custom segmentation maps, where you can see inside of here, the road is painted with a light blue. We have some barriers in red, green for foliage, and all these other bounding boxes that come built in, right? All this comes out of the box. What you're seeing here is completely open source. We even have things like 3D playbacks, right? So if you want to see your car actually drive through, we have some plugins built in, which allow you to do these playbacks. You have the map on the bottom. It's going to give you the full context of what you're working with here, right? And this is the most important part, right? Because when we begin to start working with data, such as NVIDIA Omniverse here, like as we see here, we want to make sure that we're able to bring everything that the user and that machine learning engineer will possibly need when they begin development. So in this case, we can look at some samples here. Once again, we have some radar points on the right. We can even turn on our LiDAR points. But as Gotham was mentioning, everything you're seeing here is completely synthetic, right? This is a synthetic data scene. All these LiDAR points, the radar points are coming from synthetic scenes. And we can begin to visualize much more than just some bounding boxes, right? So I'm going to turn these off just for visualization. We can also do things like semantic segmentations, color by all number of things. If you want to color by value or by field, you can get any kind of flexibility here. So when we have semantic segmentation, sure enough, here are all our cars. But we can also do instance segmentation. We can do depth maps. We can even do surface normals as well, right? So when we see this, it's all just a matter of what you want to be visualizing and bringing that context right in front of you. Of course, this all comes with flexibility for things like evaluation, model comparison, all comes built in. So what you're actually seeing here too is actually on our enterprise version. It makes it a little bit easier for me since it's all web-based, backed by the cloud with 51 Enterprise. Allows you to kind of easily flex around these things. We can even do things like embedding views, right? Where we have two scenarios in my data set here. We can see this nice downtown San Jose drive where if I grab any of these samples, I can pull these up. So if you have embedding visualizations on top of it, you can work on it. And one thing that we really want to touch on here is why it's so important to have synthetic data and driving data, especially. Talking to a bunch of different customers and users that are in the AV space, it's not a matter if I should use synthetic data, it's how much synthetic data I should use, right? I'll give you everyone here a really great example, and Gotham, always feel free to chime in this, right? We're going to look at a case here where I am driving on a street here. We don't need to look at the 3D for this case, but I'm driving down the street here on a nice wide highway, and we see this parked car. We see this, I believe, is a person standing next to the car, and we're going to find a pretty poor trend here. That what happens when we move forward in time here, this person is going to make a really poor decision by walking in front of the highway in front of my car, right? We can't really generate these scenarios in real life, right? The story I always like to joke around with, like if my self-driving car hit grandma, I can't go back and retrain my model and then tell grandma to step in front of the car again. I don't think she'd be willing, and it's probably not the safest way to test. So we can start generating these scenarios in simulations such as this, with things like neural reconstruction and adding actors in later, or in these synthetic cases like this, where you can begin to add these edge cases, these outlier scenarios, these 1 in a million things where it really comes down to the 1 in a million that's going to be the most crucial to make the car safe, right? We don't have a lot of training data of people walking in the middle of highways, so we can use Omniverse to begin to cover these gaps for us. All of this, also, of course, like I mentioned, we can do with the neural reconstruction. As Gotham showed, we have some scenes here. You can store any amount of videos on top of your scene, but the real one that we want to be showing here, right, is this one here, where on our top scene, we have real data. On the bottom scene, we have a neural reconstruction, right? Those aren't images. That's a 3D world that we can actually explore, work into, move, add, change bounding boxes, and all this comes flexible right out of the box with the NuRec, right? All you have to do is add in your AV data set, put in all the important components such as poses, cameras, sensors, whatever you have available from your real life drive, and we're going to be able to visualize this. And just to prove that this is truly a reconstruction, I actually have the live demo running locally here on our computer, where we can begin to kind of step through this time frame. I apologize. I don't work for NVIDIA, so I don't have the world's biggest NVIDIA GPU. We're going to have to bear with my
okay,
little GPU. But you can see all this metadata, all these chunks. I can see if I turn these off, I can turn off the bounding boxes. Everything that you're seeing here is actually something that can be edited inside of our reconstruction. So if you want to change that FedEx truck into a UPS truck, if you want to remove this San Francisco bus to a different type of bus, it's all customizable, right? So there's really so many options. There's really endless customability, depending on what your task is, to really start working with this in the best way possible.
Yeah, I mean, a couple of things I'll add is the core reason we are encouraged and very excited by this partnership is people have lots of real data and their fleet data sets are kind of sitting there. And sometimes people are like, well, how do I put this to use? And Voxel 51 and team have been working with a lot of AV customers and ADAS customers, which means that these data sets are kind of sitting in a workflow which is ready to use. So by providing Voxel 51 with these reconstruction workflows and the Omniverse workflows, we're creating this data flywheel where people can take their existing real data sets, reconstruct them, bring them into a simulation environment, connect them to other partners doing sensor simulation with us, and create this, create diverse, interesting data sets, which you can then again visualize and inspect and curate through Voxel. So they're kind of integral to our workflow and how all these pieces are going to scale, especially with the large community of people that they're working with. So we're very excited to see this partnership come to life.
Yeah, and it's been a pleasure working together, right? I mean, we're really bleeding the edge right now of what is possible in the AV space when it comes to building the best data sets possible and building things just, not even just managing the data, creating synthetic scenes, but ensuring that your scenes are high quality, being able to find these outliers, being able to search across potentially a petabyte of data to find exactly what you're looking for in your AV data set is really the most crucial problems that we see happening today in the AV space. So if you want to pull your slides back up, Gotham, I can hide my demos away. I'm glad the demo gods were very favorable to me today.
They were. It looks great. It looks amazing.
Great.
All right, let me swap the screen here. Okay, Gotham, your screen's up.
Yeah. Let me continue and show some more stuff, right? Because I think it'll help paint the picture. So we talked about what we're doing with Voxel. I want to share that for example, the aspects about generating novel views. So novel view synthesis for AV is typically a commonly requested use case, which is I have a drive, I've reconstructed it, and I'm going through the drive. But now I'm going to shift my car position by like 6 meters to the left because I wanted to create a new perspective and generate a novel view. And it's maybe hard to collect this kind of data, right? Because you can't drive in the opposite oncoming lane. But if you want to create that data, when you reconstruct it, often you run into artifacts because the novel view and you're trying to render a Gaussian, you get these things which you might not have seen, occlusions. So to fix those artifacts, we have a foundation model called Fixer, aptly named, which allows you to sort of in-paint and fix certain artifacts as you first reconstruct. So when I say Fixer in the loop, it means you're using it as part of the reconstruction process and training the Gaussian. And then when you're rendering with Fixer, which is as a post-process step, you'll see that progressively we've improved the quality. All the crosswalk lines look clean and nice. It's because, and it's almost giving you the feeling that you're rendering the data from a completely new point of view, but it looks accurate and there's no artifacts on the ground. So this is all made possible because we've trained this model on relevant AV data to make it understand gaps and fill in those gaps when you're creating novel views. So these Fixer has been released as a NIM. You can go find it on Hugging Face. We're happy to share the link, and the community is already downloading it a lot and trying to use it. So looking forward to people in the community trying this model. Let me talk about another major thing that NVIDIA is working on, speaking of foundation models, and that's NVIDIA Cosmos. So NVIDIA Cosmos represents a family of foundation models, workflows for post-training, curation, creating your own foundation models, as well as other scripts and functionality. We are only talking about the Cosmos transfer part of it here. We'll definitely talk more about the other Cosmos workflows, and please be sure to check out Katie's blog on how Cosmos is helping AV in general. But the transfer workflow specifically is I have simulation at some level, or I have real data which I've already created, right? So on the left, you can see different kinds of inputs that people could start with. So this could be, semantic segmentation, depth maps. It could be, sort of a HD map or a high definition map level representation with bounding boxes for the different agents. We're able to take all those inputs along with a text prompt explaining what you want to see in the scene and create these rich, realistic, diverse sensor data sets with variations, right? I can ask for nighttime, I can ask for snow, fall, different weather conditions, rain, lighting. This is especially important for things where you're trying to model particulate effects, things which are hard and very hard, very time consuming to model with physically based simulation, right? So if you, let me show a couple of examples. This is kind of put this in context. So one of the biggest platforms for doing simulation is Carla. So what we've done is we've enhanced Carla with our NuRec capability. So you just saw a demonstration of that from Dan explaining how you can take real world drives and reconstruct them. So we took the reconstructed drive and we actually made it a simulation environment that you can drive through with Carla. So in Carla now you can place all the actors you see in the scene which are moving are actually Gaussian vehicles which are floating through a Gaussian point cloud, and you're rendering this camera point of view to create this synthetic data. And this is all working in Carla. So we're planning on a release with this. Hermandro Sanchez, who actually runs the Carla Foundation and is working with us on this, couldn't join you guys today. I'm hoping that he can give an actual live demo of this when this becomes available. But what we've then taken is we've taken that real world drive, replayed in Carla, and now created a bunch of variants, right? So a snowy variant, an evening, sort of a dusk dawn kind of variant. This is kind of low lighting with street lights. We've created all these variants from a real world drive. So it's grounded in the physics of the real world drive, grounded in the events that happened, and still giving you the variations in a very controllable manner. You retain all the ground truth information. So very, very quickly, you're able to scale the amount of data you have and get to those corner cases which are typically hard to get, right? So that's kind of our main focus with this, and we want to enable the community to do this at scale. Let me show you another way in which Carla is being used. So we work with our partners for Telix, who do a lot of work in verification validation. They work on the open scenario language and the standards, and they've built a lot of tooling for simulation in this area. So what we've done with them is we created an object level simulation of a car driving down a road. They are using Carla to model the physics of how the vehicle drives, because you can create a drivable mesh with a map in Carla and model the physics. So for Telix, in combination with Carla, is able to give you an object level simulation, which is boxes moving on a road with reasonable dynamics. We're able to then take that view and project it to the image plane with the right lens distortion models. That's what's going on here. And then we're able to use Cosmos Transfer. So this is a Cosmos Transfer AV HD map model. And this model allows you to take the projection of a map on an image along with the text prompt and create sensor data, right? So this is kind of the flow we're showing here. And because GTC was in Paris, we decided to simulate an event of a near miss in Paris. And you see the car kind of braking, letting the other vehicle pass, and you have this realistic data set. So the entire point being here, we really see an acceleration in how much like how little time people need to be able to create realistic data sets. Whereas in the past, you'd have to create either the 3D representation of the world, model all the materials, the light properties. Now all of that gets substituted with using a foundation model to create a data set. Of course, you have to post-train this data to make it work for your sensor configuration. Let's say you want to drive in a new location, which wasn't in the original Cosmos training set, then this kind of post-training workflow we think is kind of the key to growing in this area. Let me show a couple more examples. So Carla especially is a massive developer platform. Another partner of ours, Inverted AI, is working on building ego and traffic behavior models. So what we did at the top is basically a simulation of Inverted AI's driver model logic. And that logic is driving the agents in Carla. This is available today. You can go try it out. And because we're announcing a version of Carla that is connected to Cosmos Transfer, you can take the renders from Carla and post-process them to create interesting variants. So what we've shown here is four different variants of the exact same drive that happened in Carla, but with forest in the background, with a beach, with skyscrapers, all these different domains which are very hard to model individually. We've kind of created this scale of content in a very quick and easy way. So we're very excited by these partnerships, and I hope many people in the community will try these out. Come ask the Carla team, go talk to Telix, go talk to Inverted AI. We're excited for you to reach out to all the partners.
Beautiful.
One last one, which I think is very interesting and people might not be thinking about, is we actually work with proving grounds too. So MCity, which is the University of Michigan proving ground team, has expanded in recent years to become not just a physical proving ground, but a digital proving ground platform. And we really see this kind of expansion of like, how do you take a physical proving ground, which maybe is not so interesting, doesn't have a lot of, different, you can only have set backgrounds and set environments. How do you make that useful for people? So here we've taken a real world, a drive from a proving ground map, and we've converted it into a sensor simulation with Omniverse. And then we put that through Cosmos to give you, for example, a drive through a mountain scene, right? We can also, convert it to a nice day, blue skies and white clouds, or we could give you a desert landscape and you're driving through the Grand Canyon, right? So all these variations are made possible because of the foundational knowledge that is in a Cosmos-like model. You can take that internet scale data and use it in this context in a very targeted way to get all these variations. I wanted to give Dan some more time to chat because we have some demos from here, but I think, Dan, you covered it. Anything more you want to add?
No, I've just been hammering home. People are asking some great questions in the chat. So I've been answering them alongside. So some really great stuff. One question I'm interested, maybe you have some input here, Gautam, is whenever you're passing in these things to Cosmos and stuff like that, which do you find is the best additional inputs to pass in, whether it's candy edge, depth, segmentation, pose, LiDAR? How do you find that impacts the outputs of Cosmos and the related models?
Yeah, fair question. So the thing which we notice is what you're trying to do kind of very much dictates how Cosmos is useful, right? So in this case, which is I wanted a mountain background in the scene. So we specifically actually went and took out all the background assets out, and we're like, okay, blue sky helps us paint the picture. You can put skyscrapers there, you could put mountains there. So if that's one of the things which is tripping your model up, then you would focus on maybe eliminating those assets in your physically based simulation so you could insert actors. If, for example, you're most interested in having different lighting and shadow under the vehicle, I might not even use the RGB view. I might just stick to a semantic view because that has no shadows baked in. And I would then say, hey, Cosmos, take the semantic view of the scene and create different variations where the sun is positioned in 5 different ways and the shadows from the vehicle extend in 5 different directions. So it's being smart about what outcome are you trying to get out of it and how do you use the conditioning inputs to get that outcome. Right. So if you also in some cases you want to let the model imagine some things, right? If you really want the double yellow line to stay, then maybe don't feed if you feed an input which has no double yellow lines. Let's say you took, you didn't model the semantics of the line and you didn't feed that to the model. It might not even care, right? It might not put a couple of lines there. So you got to find this balance of how much do I put in the prompt, what kind of conditioning, and what is the outcome I want to achieve, and reverse engineer to some extent what are the best practices. And the key thing is we're all trying to find the best practices. So the best way to do that is to go try it. All the Cosmos transfer models are available publicly, so I recommend people please go try it out. Come back to us with feedback. We're very excited to work with the community on this.
Very cool. That's great. And like Dan has mentioned a minute ago, we've got some great questions here. Do you guys want to take a few of them now? I
think it's a perfect time. Yeah, let's hammer some of them home.
Okay, cool. All right. So earlier in the stream, we heard back from. I'll take this out so we can all talk. Let me know if you want to bring your slides back up, Gotham or Dan. We'll do that.
Yeah.
Okay. So earlier in the stream, we heard from a YouTube viewer how this would work in the air. I wonder if I put this in my UAV plane, what will happen?
Great question.
Chaos. No.
Do you want to go, Gotham?
Sure.
I don't know.
I think, let's see, how would this work in the air? So the 3D content workflows that were created in Omniverse and rendering, those workflows extend to any domain, right? We are working on that for Metropolis, for smart cities. We're working on 3D content with Isaac Sim for simulation for pick and place robots. We're working on Groot for humanoid robots. So this what you saw was kind of a vertical specific implementation for AVs. You can imagine this extending to multiple domains. The models and the workflows themselves are kind of generic, and we're kind of building this expertise in one area at a time. So I wouldn't be surprised if in a year we're talking about submarines and drones, and who knows what's going to be the next frontier. So.
Amazing. Okay, that's great. Thank you for that great question. All right, Just Enough Keys asked, why not process environments for your fractal dithering as opposed to Gaussian?
It's not a question of this method versus that method. Our approach has been very much, we keep taking feedback from the community. We see where the market's going. We invest, we build, and then we repeat the process, and we repeat the process, and we do it again. So NVIDIA is going to keep investing in rendering in AI for the next, future. So this isn't going to go away. So yeah, we're happy to learn more if you have a specific request on how to do rendering.
Yeah, and just to add to that too, right? I think the important thing here is to keep in mind what is important, right? A lot of times the model here, as ironic as it sounds, is not the important part here, right? Whether it's a Gaussian model or fractal dithering, there's going to be a new one next year. That's going to be the new hottest thing that if you're not using that, everyone's going to be upset. The important thing is being able to make sure that the data set you're working with can easily go into that next rendering the moment it comes out, right? Like you don't want to fall behind. So if you build this whole pipeline behind a single rendering method and it becomes outdated in the future, it's a significant technical debt to now pivot to one, right? And kind of what Gotham's hinting at here is the neural reconstruction tool is built to be able to adapt to whatever that next rendering form of the future is going to be. So if there is a new hot one that comes out, you don't have to change too much. You don't have to change the way your data set's configured or anything like that. Just set the flag for the new hot sauce model that just came out and use that instead.
And just to give an example, I mean, we started with NeRFs, and then we switched to Gaussians, and now we're doing Gaussians with ray tracing, and then tomorrow will be the next thing, and this train is going to keep going. So, yeah. Okay,
cool. This is along the lines of the early question we got regarding air, but in case there's anything you want to add here, but I think you answered this pretty nicely earlier. It's for aviation simulation use cases, and I know in general, lots of different companies, lots of different developers leveraging Omniverse and this technology for lots of different things. Just because we're not doing something specific doesn't mean others aren't. But I don't know if and you want to add to this at all.
I think the one thing, just to add a little bit color, right? It's a little bit more left field. Is Omniverse is really good about keeping intact the sensor data, right? And when we think about aircrafts, there's not a lot of things to bounce off light in the air, right? So LiDAR doesn't work the best. But when it comes to radar, a lot of those kind of more special Ismith-like Doppler range values are being contained to the best of their possibility inside of Omniverse, right? So when it comes to expanding to these use cases in the future, I think it's totally on the playing field, especially when we think about things like not actually in the air, whether it's a hangar, we're doing repairs onto the planes and things like that. It's totally in play today. And I think it's really exciting about kind of where the autonomous UAV space can go. knowing that these sensors are being maintained the best they possibly can be.
Oh, Enmar, you're on mute.
Sorry. Classic host mistake. Clash Royale is asking, does Omniverse provide radar sensor data?
Yeah, so no, it's a good question. We have generic models for radars, and we're able to produce radar cubes. We can go to the tracklet level. We are able to produce radar data as part of Sensor RTX, which is our sensor simulation service. So short answer is yes. Happy to discuss more.
Amazing. And look at this question from our Omniverse ambassador, who was just at GTC Paris, Lychee AI, otherwise known as Muammar Bey. He's asking, which of the multimodal, multi-control inputs are the most useful? I think you talked about this a little earlier, actually. But in case if anyone's tuning in afterwards, you want to just touch on this really quick?
Yeah, I can say it again. So if your goal is, and this is also about fidelity and how much fidelity do you want, right? So if you really want fine control of how a specific actor in a scene looks, so let's say you want it to be an SUV and you want the vehicle in front of you to be an SUV, which is driving through the scene, and the pedestrian in front is doing very specific actions, then you might say, hey, you know what? I want Cosmos to kind of paint in the edges, and I want to stick to the outline of the actors, maybe, but change the color, change the lighting, make the pedestrian have a red shirt instead of a blue shirt. You can do all those things, but then the way you would ask for it is, hey, give me segmentation, give me canny edge, because I want to maintain the outlines and bias more towards preserving the edges of the objects and then filling in. Versus somebody says, you know what, I don't care if it's an SUV or a truck or a car. I don't know if it's a kid or an adult. I just want a box for a pedestrian and a box for a car. You might just say, I'm okay with the HD map and a bounding box for the object, right? So, and you might give, let Cosmos give you the options and you choose, because you're okay with flexibility. So depending on the level of specificity you want, you might choose different inputs. And that's just one example, there's more. So
that's great. It's really, really helpful. Okay, this is a question from a regular viewer. Hey, Tom, how you doing? Tom's asking, in most autonomous driving demos, front camera LiDAR is going to be the main sensors. What fallbacks?
Yeah, great question, right? I can take this one. There's always going to be more. And the super exciting thing about AV, as Gotham mentioned earlier, is there's no right answers. No one has, Gotham drove into this meeting today. He drove himself. He didn't get a self-driving taxi to take him to the office.
Not yet.
Not yet. So we don't know, right? We don't know. And so depending on who you ask, they're going to give you different answers to that question. That's why it's super exciting about this. Some people have multiple cameras pointing, overlapping to make sure they can cover for these kind of things. Some people believe that having multiple LiDAR. Some people have LiDAR and radar, right? So there's no one answer. The idea is, one, if a LiDAR instantly fails, it just turns off on your car, pull over. If you got a flat tire, you would pull over. This is a similar situation when it comes to self-driving. If your most crucial sensor completely fails, you have to pull over. It's just for today, for tomorrow, for the foreseeable future. Same thing goes for cameras. If there was completely occluded front camera and the car's driving forward, pull over, right? It's not it's not the best answer, I guess, but there are multiple approaches to this with camera overlaps, multiple sensors, fallback systems, things like that. But the correct answer is flat tire. You pull over.
That's so, it's so obvious, but I don't think I've ever heard it explained like that before. And it makes total sense because I think a lot of people in their head, they're assuming if something breaks, things are going to explode or something. It's just game over.
Yeah, right.
It's not really that dramatic. Okay, very cool.
I was an automotive reporter in a past life, and a common question was the trolley problem of if an autonomous vehicle is running away and can either hit one vulnerable person or many vulnerable people. And someone was answering that one time, and they just said it would stop.
Yeah,
perfect.
Makes sense.
Well, here's a great question from a LinkedIn viewer. Is it possible to combine interior sensing like in-cabin cameras or driver monitoring with ADAS simulations in Omniverse to generate hybrid data sets for new multimodal use cases?
Yeah, I haven't worked on in-cabin myself, but I can say that we worked on sensor simulation inside the vehicle in the past with digital actors and humans. So this area is definitely growing. But yeah, it's a new way of looking at the problem, especially as you have cases of human, driver handoff to the vehicle and so on and so forth. This will become more and more important. But most of the use cases we're focused on right now are focused outside the vehicle, definitely within the realm of possibility.
Very
Totally,
cool.
right? Yeah.
Okay, here's a question from a YouTube viewer. When will Cosmos be real-time basis? For example, we need to control the car's direction on turn-by-turn basis, like a racing video game.
I hope it becomes real as soon as you say it. We want it as much as the community wants it. Our focus is very much on, hey, how do we accelerate the models? How do we distill the models and create versions that can run faster? Where NVIDIA's inference GPUs it's our entire focus is how do you make inference faster? So if you combine that machine of making inference faster with distilling the models, we're working towards making this a reality in the future. So.
Amazing. Here's a great question too, from LinkedIn. Daniel, how exactly are those edge cases identified using Voxel 51? And once identified, is there a way to expand or generalize them?
Yes, right. So this is a great question. And there's a lot of different ways you can answer it. But the main way is the best way to find edge cases today, two methods. It's either through VQA within BLM, right, to find specific scenarios. You can do this very lightweight with very lightweight BLMs, such as like Phi3 or small llama models, things like that, where just pass over all your data set. If you can afford this compute-wise, say, is this a dangerous situation? If it is, how dangerous of a situation is it? And if it's based on how dangerous, explain why it's dangerous, right? So it could be someone just cut you off. It's dangerous. It's high dangerous because it's raining or there's an object in the road or whatever it is, right? And as long as you fine tuned on a data set for this kind of stuff, it works pretty well. That's one. It's not my favorite way to do it. My favorite way is usually in embedding spaces, especially text and visual embedding spaces. I know Cosmos is actually developing a model internally right now to do something exactly like this. So I can type into 51, for instance, and say, find everyone that cut me off. And it's just going to pull all the cut off videos or images right for you right away, right? Same thing is once you identify a single cut off in your data set, you can click on that sample and say, find every other sample that looks like this. You don't actually have to say textually how it looks like it. And it'll find all the other ones where it looks like someone else cut you off, right? And you can expand this across your entire data lake for petabytes of data and things like that. There's a significant compute front end that has to happen here to have the embeddings on all of this. But there's multiple different ways, whether it's searching across metadata, doing embedding searches, or using BLMs to find exactly what you're looking for. The most important part is to be flexible for what you're looking for, right? I'm never going to see your data. Voxel doesn't see your data. We don't have a little Voxel consultant agent that sits next to you and tells you what to do. You're going to be ultimately the master of your own data, the expert of your own data. And we aim to provide you, both us and NVIDIA, with the best tools to find what you're looking for.
Amazing. And Voxel's website, very easy, voxel51.com. Highly recommend. You have a great also community.voxel51.com. If you want to engage with the community. Docs, I think, is docs.voxel51.com. You guys have it all figured out.
Make it simple.
We have a great question again from Omniverse Ambassador Mormar Bay, aka Lychee AI. I'll put this on the screen. How many videos and images would I need to fine-tune Cosmos for my task? I guess it depends what the task is, but what should be the real synthetic ratio of training data?
Yeah, very relevant question. So Cosmos might be inherently well suited for some tasks. So maybe let's say you want to try it for agriculture use cases, right? And if it hasn't seen enough data of fruit, of a specific type, and you're trying to do a pick and place robot that's, trying to select that fruit out of in a farm, you might have to go train a specific post-training model with enough data so it starts picking up that object. It has a general understanding of what are objects, so you don't have to teach it that, but a context-specific or a specific sensor configuration or specific placement of actors, all these things are things that you might need to fine-tune Cosmos for. I can't give a number as such. It's not a binary choice. So you would have to fine-tune, try it out, run an experiment, and that's the best way to kind of get this thing. This question of real and synthetic, I'm assuming you mean for the downstream task and not for Cosmos fine-tuning. So the real and synthetic, I hope we'll get to a point where the line starts blurring and you're starting to ask yourselves how much real data and how much Cosmos post-trained data am I going to be using, because it's all based off of real data, and you're just creating variants out of that real data. So it's very much of, hey, if you have, as Dan was saying, you find that you're not doing so great in snowy conditions, or specific somebody cuts you off and you don't have enough examples of unprotected left turns, you're going to just add extra data of those unprotected left turns and keep asking the model, hey, did I do better? So this iterative process is what we see is most useful, and we want to make that iteration easy for you with tools from partners like Voxel. So.
Go ahead, Katie. I'll add afterwards.
Oh yeah, just to piggyback on that, for kind of one example post-training use case, our research team came out with a paper at CVPR, Cosmos Drive Dreams, where they post-trained Cosmos to generate multi-view camera data from single camera view. And I believe in the paper, they said they used 20,000 hours of driving data for post-training. But Predict2 in the pre-training, when it was pre-trained, used a greater share of AV data. So as these models get better and better and larger, ideally, you would need, in theory, less AV data for post-training.
Yeah, and just to add on to the synthetic real ratio here for the post-training task, if you asked me, based off real customers, real AV shops that are doing this today, I've interacted with these engineers, that line has already been crossed, right? They are training on much more synthetic data than they're training on real data today. And it makes sense when you think about it, right? So 95% of the time, your car's driving in easy scenarios, down the highway, pulling out of the garage, stopped at a stop sign, whatever it is, right? And the car is going to do fine. When you get to that tricky area of a zebra cross, if you don't know what a zebra cross is, right? It's the crosswalks, like in the middle of the street. They're the white lines. You can drive through them if no one's walking, but if someone's coming, you got to stop, right? If my car failed to stop one time and like nearly hit someone, one, I'm not going to go nearly hit someone again in order to capture this data set, right? And two, if I identified a poor area of my data set, well, yeah, of course, I'm going to try to make it as well covered as possible because I've identified this gap. I'm going to do it during rainy days. I'm going to do it during snowy days. I'm going to add 10 more people into the zebra cross. I'm going to remove people from the zebra cross and see what happens, right? Because now I've identified this crucial area in my data set where I need to fix it. So it's okay for me to kind of swing things around. And what's super unique about driving data is that the end goal is a safe driving car, right? It's not to have a car that knows what looks like a person in GTA versus a person in real life. It's not to say that it has to have everything be perfect all the time. The goal is to drive safely, right? So as long as the car drives safely, the amount of synthetic data you add, as long as it's not becoming overly biased towards the synthetic data, which a lot of papers in the past CVPRs will tell you that that does not happen very quickly, you should be training on a significant amount of synthetic data.
That makes total sense. Thank you for the great question, Marmar, as always. Okay, I can't believe how fast time's moving. All right, we got a couple of good questions here. Let me see. Trying to see which one we could do here.
I can quickly. I saw one question about the origin of Carla, and this is a question I had asked Herman earlier, so I can answer it quickly. Carla means car learning to act. Carla.
That's great. That's great. I think that question was from Papa Chuck. Okay, great question, Papa Chuck. There you go. All right, this is from LinkedIn. Michael's asking, how does NVIDIA ensure simulation models not only generate realistic training data, but also long-term effects like central aging, environmental changing, rare edge cases? I think we talked earlier that we have a specialist on our team who can probably help this person on Discord with a more complete answer. Is that
I think we can. I mean, we can talk through.
Yeah.
it.
Okay. Go ahead.
The environmental changes we kind of already showed, right? We're trying to model, for example, snow and rain and all these effects. Sensor aging, noise, lens distortion issues, aberration issues, dirt on the lens, droplets. All these things are something where Cosmos can augment an Omniverse render. Modeling a droplet falling, rolling down the lens is not as easy as it looks. So these are the places where we'd rather work with the foundation model, which understands these contexts and can add that in an easy way. And the other part I kind of want to mention quickly is Halos is kind of a set of best practices. So over time, the best practices will start to include more and more simulation, and will show how the simulation ecosystem ties to Halos and how developers can then use those workflows. Right now, we wanted to share our best practices and start the conversation, which we've done. Much more to come. So.
Okay, great. All right, let me see if we can do lightning to tackle a couple questions quickly. I'm going to go most recent to earlier. Jesus, are there any scenarios where you train fully with synthetic data sets required little to none domain adaptation, given the quality of the output by Omniverse? I'm not sure I understand this completely. Do one of you guys?
Yeah, the interesting part about this is, again, the use case, right? Let's say you have a really mature stack, and your stack has seen all kinds of data in the real world, except you haven't seen that one thing which has been giving you trouble, which is there's a new kind of pallet from this delivery company, and the pallet keeps getting dropped in front of your garage, and you want to back out and avoid that. So all you have to do in those cases is add extra data sets of that inserted synthetic object, maybe with just Omniverse, and render it. And if your stack is smart enough, it'll start recognizing that actor, that object, and start detecting it. But if your stack is not as mature, then you have this question of, hey, I'm actually not doing well because there's a domain gap shift. And instead of focusing on domain adaptation, you can focus on the actual downstream task. So nuanced question, requires some more thought. Yeah.
Okay, cool. Here's a question on hardware from Lucas. Can it be fine-tuned with 8 RTX Pro 6000s? The documentation only mentions 8 times 80 gigabyte GPUs.
I mean, we're definitely making Cosmos fine-tuning work on all our NVIDIA platforms. So Blackwell is definitely going to be a priority for us. So that's kind of what I would say. Anything else to add, Katie?
No, I think you covered it.
All right.
Here's a kind of broader question. Will the use of traditional 3D environment simulation be completely replaced by Cosmos?
I mean, I have thoughts on this, and I'm open to other suggestions, which is 3D environments are great for certain aspects, right? If you're trying to model occlusions, if you're trying to model LiDAR and multi-bounce, multi-path effects for radar, doing that really well and doing that in a repeatable way is hard. A foundation model will get there, Cosmos will get there, but right now the groundwork is still in very much how do you do physically based simulation. So for some aspects, 3D environments are needed. And if you're doing hardware in the loop simulation and things like that, right? If you're doing, hey, I just want to generate realistic sensor data and start, training my model against edge cases, then, you could get away with doing everything in Cosmos. And you might get back to the question what somebody asked earlier, is the level of fidelity. If you want a very specific animation to happen and you want one specific maneuver, you might choose to use a combination of Omniverse and Cosmos. So the sweet spot's somewhere in the middle, and it'll keep shifting as the technology evolves.
Right, and just to add to that as well, right? It's important to highlight where we've come from for synthetic data. I mean, going back like 5 years even, right? You probably had to have at least 18 people. There's like a study that came out like a couple of papers ago or a couple of years ago, where it's just a big game of telephone. You're telling one guy who's really good at the engine to build this, another guy who's designing the assets, another person who's placing the assets, another person's animating the assets. So much of that we're not doing anymore, right? It's much more like 3 to 4 people to build a full stack data set from synthetic data. I think that number is only going to decrease, right, over time, to make it easier where you can go from data coming off the car all the way to synthetic 3D environments with one person with the aid of an agent and tooling similar to what we're looking at today to do this, right? And that should be the goal, right? The easiest way to get to the best data set possible.
Very cool. I'm scrolling through your webpage really quick. Really, really great information here, I could tell. I highly recommend everyone check out voxel51.com. Also, if this topic has interested you, be sure to like this live stream. It will really help others discover it as well. And it also always helps the ecosystem when developers are discovering this work together. And obviously subscribe if you want to be part of the community more and join our Discord server. This has been fantastic. I can't thank you each enough. Before we go, I'm going to ask if you guys have any final thoughts on maybe something we could have maybe left out, or you want to leave people with your parting advice. So think about that for 1 minute. While you're thinking about that, I also wanted to showcase, we did this last week and it was a big hit. We highlighted a developer, unrelated to the topic of live stream, but this developer is doing really cool stuff and sharing on LinkedIn, which is just amazing. Such a great platform for engaging with other developers. We highlighted Lightwheel last week and Mustafa, and that resulted in right now we're talking right now about having them come on a live stream. So really excited about that. But I wanted to highlight just yesterday, Omniverse Ambassador Michael Wagner shared this. Hard to see on the screen. I'm going to post the link. But basically, he released a lightweight NVIDIA Omniverse kit extension that connects to a Docker container running the Hunyan 3D model. So it's now available as open source. So this is fantastic. And he's got the GitHub link also in the comments. So I'm going to post this link in the chat. Highly recommend that people follow Michael Wagner. He is just fantastic. He doesn't post every day, but when he posts stuff, it's worth reading. So I would highly suggest people follow Michael Wagner on LinkedIn. He's works at Epilog.ai and also founded SyncTwin, which helps enable companies enable digital twins for their use cases. But really enlightening. And I believe right now he's at the Automatica Conference 2025. So if you want to meet with him there, that's happening. I think Dan told me to the 27th. So all week this week, you can hook up with Michael Wagner. Feel free to DM me if you need help. And then also another ambassador also just posted this yesterday that he's wanted to show off 3D Gaussian splatting and NVIDIA Omniverse and Isaac Sim 5. So he's got a nice little video there showcasing everybody. So highly recommend you follow Michael Wagner and Scott Dempsey, really great developers, very active in our community, not only LinkedIn, but on the Discord server. Very helpful to our community. All right, so now I've given you all 90 seconds to think about your final comments. Why don't we start with Katie, since you helped me with the beginning of that lightning round of news slides. What do you want to leave people with?
For sure. I mean, I think just kind of ending on a zoomed out view of everything. As I mentioned kind of at the beginning, this technology has been under development for 2 decades. I started covering it as a reporter 10 years ago. What's happening now, it really feels like the inflection point for it really to break through wide scale deployment, and it's just really start changing the way that we move. I think what's happening with neural reconstruction, what's happening with data generation is really accelerating development in a way we haven't seen before. So it's a really exciting time for autonomous vehicle and physical AI in general, extending even to robotics. And it's, we're doing it for the grandmas and the dogs. Be a much better world for them.
Thank you. And thank you to Tully for also joining us there a little bit earlier. I think he's taking a nap right now, but
yeah, he's a good
pet for us. Okay, Gotham, you're up. Any parting words?
Parting words is, if you're interested in this space, if you're working on simulation, autonomous vehicles, data, if it's not autonomous vehicles, but it's autonomous robot, could be a dumper truck, could be a delivery bot, could be any of those things. We're talking to everybody, right? Just to give you, a sense of who we're talking. We're talking to everybody. Everybody's super excited about this growth in technology. We have partners like Voxel who are kind of helping us scale this technology and give it to many people, along with the others you heard today on the stream. So my main ask is come work with us, reach out. If you're building a platform, try Cosmos, try NuRec, reach out to the team, and we're happy to start conversations. And looking forward to it.
And if you do need help reaching out to the team, feel free. You can always jump on LinkedIn, message me or Gotham. You're on LinkedIn also. You can also reach me via email, edmar@nvidia.com, and I'll be happy to introduce you to the right folks here. Okay, Dan, you've had the most time to think about your parting words. I know you're ready, so go ahead.
I'm ready, right? And echo right off the bat what everyone said before, right? We're building this. We're excited to give it into people's hands. So if you do have questions, there's NVIDIA Discord, there's Voxel 51 Discord. I'm always available online at LinkedIn. Just type in my name as you see it here on the live stream, and I'd be happy to connect with you, answer any questions. I think someone already reached out, so I'm excited to talk more. Always happy to kind of answer any questions. I think the last closing note I want to think about this is it's always fun to dive into topics and things like that, but to tie into kind of the big picture paradigm shift that's happening here is that we're really moving away from this previous time with especially AV data, but really any visual data, physical AI data, where if you wanted to train a model, it had to be human annotated, right? Everything had to be a person go through, draw those bounding boxes, everything like that, multiple passes through in order to get a data set across the line. And now we're seeing that shift finally to be automated synthetic data sets, giant VLMs annotating your data sets. And Omniverse is playing a huge part of that story, right? Being able to find these gaps in your data, to be able to fill those gaps in your data set, train these giant VLMs that are going to be driving cars, that are going to be labeling your data, that are going to be finding miss cracks in your manufacturing lines or whatever it might be, right? There's a huge story being told here of shifting away from human labeling and very costly annotation cycle to much more cheaper, much more efficient, and just overall higher quality data sets, right? And so it's really, really exciting time to be in visual AI, physical AI, to work with these kind of data sets. So if anyone has more questions about kind of what that paradigm shift looks like to more data-centric things like that, feel free to reach out to me on LinkedIn or check out the Voxel 51 website, as we've been showing here, where we have tons of information about things like verified auto labeling, kind of data set first mentality, and a bunch of blogs about this as well.
Amazing. Wow, that was perfect. Perfect. And thank you all for joining us today. Thank you all for watching. Great questions and comments, lots of thank yous, and really impressive comments and throughout. Really fantastic information. Gotham and Dan, those presentations were very helpful. Katie, you helped set the stage perfectly. Your journalistic background is super sharp, as I can tell. So everyone should check out Katie's fantastic blog that really helps also dive into the topic. Check out Voxel's website. Have any problems? You want to look back on this? This is available on our YouTube channel as a replay. Just go to the stream section. You can always also go to the Omniverse Discord server, which will we have an area for this specific live stream, a thread. So all the resources are in that thread. And we'll be sure to keep an eye on those questions there and forward over to Dan and Gotham and Katie as needed. But thank you all very much for joining us. It's been a fantastic over an hour now, and it went by too quickly. So until next time, we'll see you on forums. We'll see you on Discord, and have a great rest of the week.
Thank you.
Thank you, everyone. See you online.